We'll start in about 5 minutes. Zach, Chloe, and Holly. We'll start in 1 minute. In the next section, 4.3, we have more word problems that involve finding systems of linear equations and then solving those systems. So here's our first one. This is referred to as a mixture problem. So just a reminder of the procedure when solving these kinds of word problems. Find out what you need to find, determine what you need to find, assign variables to those quantities that need to be found, and then find a system of equations and then solve that system. Okay, so in this one we have two kinds of coffee that are mixed to get a total of 12 pounds at $6.25 per pound. One of those by itself costs $4.40 per pound, and the other kind of coffee costs $8.84 per pound. And we want to find the number of pounds of each in the mix. Okay, so we have two quantities to find. I'll call them X and Y. And I'll assign X to be the number of pounds that costs $4.40 per pound. So number of pounds at $4.40 per pound. And I'll pick Y to be the number of pounds that costs $8.84 per pound. Okay, so now we can write down two equations, one at a time. In the first part of the first sentence, it says two kinds of coffee are mixed to get 12 pounds. So our first equation can be X pounds plus Y pounds equals 12. So that is our first equation in the system. That's the easier of the two. But I'll frequently point out that whenever you write down an equation, each of the terms must represent the same kind of thing. So each of the terms just represents a certain number of pounds of coffee. In this equation, we're not taking into account what the cost is per pound. It's just the number of pounds. So X pounds plus Y pounds equals 12 pounds. In the next equation, we'll take into account the cost per pound. Okay, so if X pounds costs $4.40 per pound, then the value of those X pounds is 4.40 times X. This term represents the value that X pounds of coffee is if it's $4.40 per pound. We add that to the value that Y pounds is if it's $8.84 per pound. So this is plus 8.84 times Y. And then the mixture, which is a total of 12 pounds, it has a value of $6.25. So on the right-hand side, we multiply 6.25 times 12. Okay, so there is our system, and we can solve it by using either substitution or elimination. So for these numbers, it's handy to have a calculator, which I don't have up here, but we can take it a couple of steps further. I think what I will do is I'll get rid of the decimal numbers. You're not required to, and especially with a calculator, it doesn't really make much of a difference. But if I multiply every term on both sides of this by 100, then I get 440x plus 884y equals 625 times 12. Okay, so I'll use substitution. I'll pick from this top equation, x plus y equals 12. I will solve for y. So if I solve for y, I get y equals 12 minus x. And then in this equation, I'm going to replace y with 12 minus x. And I'll get 440x plus 884 times the quantity 12 minus x equals 625 times 12. And I'll take it a couple of steps further before I leave it for you to use a calculator. So we'll distribute multiplication over 12 minus x by 884. So 440x. And I'll just leave it in factored form, 884 times 12. And then minus 884x equals 625 times 12. And in the next step, I'll do two things. I'll subtract 884 times 12, and I will also combine 440x minus 884x. 440x minus 884x, that's not too hard. That's just negative 444x, negative 444x. And then I'm going to subtract 884 times 12 from both sides. So I'll write this as 625 times 12 minus 884 times 12. And then I'll write this in factored form. I'll factor the 12 out. And then inside, I'll write what 625 minus 884 is. So that's just going to be negative 259. That's what I get. Yeah, I think that's right. And then if we divide both sides by negative 444, I get x equals 12 times negative 259 divided by negative 444. Okay, so that's pretty manageable there. I'll leave the rest of that for you. A negative divided by a negative is positive. And then once you find x, finding y is simple because y is just 12 minus x. Okay, so let's move on to the next problem. Number 2. $1,800 is invested in two accounts. One earns interest at 5%, and the other earns interest at 8%. Combined, the interest earned is 7%. So find the two investment amounts. It's being assumed without stating it explicitly that the interest rates are annual interest rates, so 5% per year, and 8% per year are the two interest rates. So find the two investment amounts. So if $1,800 is invested in two accounts, then we can pick X and Y to be the two amounts. So I'll pick X to be the number of dollars that earns interest at 5% per year. So number of dollars invested at 5% per year. And Y is the number of dollars invested at 8% per year. And now we can write down two equations. The total amount invested in the two accounts is $1,800. So what's the equation I can write down that relates to the amount of money invested?
Would be X plus Y equals 1,800.
Yeah, X plus Y equals 1,800. So X dollars is invested in one account, Y dollars is invested in the second account, and altogether $1,800 is invested in both accounts. So just note that in this equation, each term represents a certain amount of money that's invested, and we're not taking into account how much interest each one of those earns in this equation. In the next equation, we do take into account the annual interest rate. Okay, so if X dollars earns interest at the annual rate of 5%, then how much interest is earned in 1 year if it's earning interest at 5% per year? Okay, let's just do a related problem. If you have $100 that you invest, and if it earns interest at 5% per year, then after 1 year, how much interest will you have earned? If you invest $100 at 5% per year, after 1 year, what's the amount of interest? So what's 5% of 100? 5. 5 is 5% of 100, right? So you can get that by multiplying 0.05 times 100 to get 5, right? So that's just a thought experiment. So if we invest X dollars at 5% per year, then after 1 year, the amount of interest is 0.05 times X. So 0.05 times X represents the amount of interest that X dollars earns after 1 year if it's earning interest at 5% per year. Then we're going to add that to the amount of interest that Y dollars earns if it's earning interest at 8% per year. So after 1 year, Y dollars will earn 0.08 times Y in interest. And then if the combination amounts to the total amount of $1,800 earning interest at 7% per year, then after 1 year, $1,800 is going to earn 0.07 times $1,800. Okay, so there is our system of two equations. When you isolate any or either of those two equations, just note that every term on both sides of the equation is the same kind of thing. Each one of those is an amount of interest. Okay, let's take this a little further. So I'm going to get rid of the decimals again. So this is equivalent to multiplying every term on both sides by 100. So when I multiply 0.05x times 100, I just get 5x. Multiply 0.08y by 100, I get 8y. And multiply the right-hand side by 100. 100 times 0.07 times 1800 is 7 times 1800. And let's use the addition method this time. So I'll leave this equation the way it is, 5x plus 8y equals 7 times 1800. And I'll focus on eliminating x, so I'm going to multiply every term on both sides of this equation by -5. So multiply by -5. And when we do that, we get -5x minus 5y equals -5 times 1800. Okay, so then I'll bring this equation down here below the 5x plus 8y equals 7 times 1800. And we're going to add these two equations. So this is the way I'm doing it. Shows what you can do if you don't have a calculator. You don't always have to multiply everything out at every step. You can leave things in factored form. Okay, so when we add these two equations, the variable x is eliminated. 8y plus -5y is 3y. And when I add 7 times 1800 to -5 times 1800, I can write that as 2 times 1800. You see how that works? And then we can divide both sides by 3. So 3y divided by 3 is y. And then if I divide 2 times 1800 by 3, 3 goes into 1800 600 times. So 3 goes into 3 once and into 1800 600 times. And so y is 2 times 600 or 1200. The total amount of money invested is 1800. There's the total amount invested. So if y is 1200, we can see that x is 600. Okay, so 600, just to summarize the result, $600 is invested at 5% per year. And the other amount, $1,200, is invested at 8% per year. Okay, let's move on to the next page. So here's another investment problem. So this time, $48,000 is invested in two accounts. The two annual interest rates are 6% and 10%. And the interest after 1 year is $4,000. So find the two investment amounts. Notice the second bit of information is not given the way that it was in the previous problem. So we have to make sure that we catch that difference. And then afterwards, it might be worth the time to go back and look at the wording in problem number 2. Okay, but we're going to start out the same. A total amount of $48,000 is invested in two accounts, and the interest rates are 6% and 10% per year. Okay, so we can pick X to be the amount of money. I'll just say the amount invested at 6% per year. And let Y be the amount of money invested at 10% per year. Oops. Okay, the total amount of money invested is $48,000. So our first equation is X plus Y equals 48,000. And then in the next equation, each term will represent an amount of interest. If X dollars earns interest at the annual rate of 6%, then after 1 year, the amount of interest is 0.06 times X. Then we add that to the amount of interest that Y dollars earns at 10% per year. So we write plus 0.10X. And what should go on the right-hand side of the equation? Okay, so the right-hand side has to be the amount of interest that $48,000 earns after 1 year.
So would it be 48 plus the 4,000? Or no?
Well, it's just $4,000.
Oh, I see.
So in the third sentence, we're told that the interest after 1 year is $4,000. So the implication is the total amount of interest that $48,000 earns in those two different accounts is $4,000. We're not told what the individual interest rate is on the $48,000. We're told what the amount of interest earned is. So we're not given a percentage about the total of $48,000. We're just told explicitly that $4,000 of interest is earned. So the right-hand side of this equation is $4,000. Afterwards, after class, go back and read problem 2 and note how it's different than this one. It's not really that hard to understand, but make sure that you know the difference. Yeah, 4,000 is So 4,000 goes into 48,000 how many times? Uh, 12 times, but that doesn't mean that the interest rate is 12%. Let's think about that for a second. If X dollars earns interest at 6% per year and Y dollars earns interest at 10% per year, then X plus Y dollars has to earn interest at a rate that's between 6% and 10%. See what I mean? It has to be within that range. Okay, but anyway, let's go ahead and solve for X and Y. So like I've been doing, I'm going to multiply both sides of this equation by 100. 0.06x times 100 is 6x. And 100 times 0.10, whoops, I need a variable y. Sorry about that. This should be 0.10y. Multiply that by 100, we get plus 10y. And then multiply 4,000 by 100, I get 400,000. Okay, we can pare this down a bit. Notice every term is divisible by 2. So if I get rid of some of the clutter that's in the way by dividing every term on both sides by 2, then this equation becomes 3x plus 5y equals 200,000. And then we could use the substitution method or the elimination method. So I think what I'll do is I'll use the addition method. I'll leave this equation the way it is, 3x plus 5y equals 200,000. 3x plus 5y equals 200,000. And then multiply both sides of this equation by -3. So multiply by -3. And I get -3x minus 3y. And then, let's see, 48 times 3 is 144. So I get -144,000. Then when we add these two equations, the variable x will be eliminated. -3x plus 3x is 0. -3y plus 5y is 2y. And then -144,000 plus 200,000 is positive 56,000. And then divide both sides by 2, y is 28,000. Okay, since the total amount invested is 48,000 and y is 28,000, you can see that x is 20,000. So those are the two quantities that we're supposed to find. So I'll leave the rest of that for you to do, which is just to write that $20,000 was invested at 6% per year, and $28,000 was invested at 10% per year. Okay, the next problem is also an interest problem, but this one is a problem that is probably designed to help you improve your problem-solving skills. So, in other words, you won't go into an investment firm and your advisor isn't going to ask you this question. Right? They're not going to make it that hard for you. So this is just an exercise in algebra and arithmetic. This one says $2,000 is invested in one account and $5,000 is invested in a second account. The total interest earned in both accounts is $480. The interest rate for the $5,000 investment is twice the interest rate for the $2,000 investment. Find the two interest rates. Okay, so now the unknowns are the interest rates, not the amounts that were invested. Okay, so there are two interest rates that we need to find. So let's pick X and Y again. You can use other variables if you want. So I'll pick X to be the annual interest rate in decimal form for the $2,000 investment. So the annual interest rate in decimal form for the $2,000 investment. So if you could read my writing. I could have started further to the left. Okay, so Y is going to be the annual interest rate in decimal form for the $5,000 investment. Okay. So now we can write down two equations, one at a time. In the second sentence, we're told that the total interest earned in both accounts is $480. So in general, how do we find the amount of interest earned? If you have a certain amount of money invested at an annual interest rate, then in 1 year, the amount of interest is the product, or what you get by multiplying the amount invested by the annual interest rate in 1 year. Okay, so the amount of money invested in this account is $2,000, and the decimal form for the annual interest rate is X. So 2,000 times X is the amount of interest that it earns in 1 year. So 2,000 times X, and then we add that to the amount of interest that $5,000 earns if its interest rate in decimal form is Y. So this will be plus 5,000 times Y. And we're told that the total interest earned, we're assuming it's after 1 year, is $480. So the total interest earned in both accounts is $480. Okay, so there is our first equation. Each of the terms represents an amount of interest. Okay, then in the third sentence, we're given more information about the interest rates. This one says the interest rate for the $5,000 investment is twice the interest rate for the $2,000 investment. Okay, so we're using Y to represent the interest rate for the $5,000 investment. And we're using X to be the interest rate for the $2,000 investment. So we can, if it's necessary, we can do a partial translation of that sentence using our variable assignments. So the interest rate for the $5,000 investment, we're using Y to be that. So I'm replacing all of those words in the first part of that sentence with Y. The interest rate for the $5,000 investment, that's what Y is. And so Y is twice the interest rate for the $2,000 investment. And we're using X to represent the interest rate for the $2,000 investment. So I can write this, Y is twice X. So how do I translate that into an equation?
Y equals 2x.
Y equals 2x. Yeah, Y is twice the amount of X. So Y equals 2x. So this is turning out to be pretty nice, actually. Y equals 2x is our second equation. So we can just use substitution since Y equals 2x. So in the top equation, 2,000, I'll rewrite that, 2,000x plus 5,000, and we're going to replace Y with 2x. So 5,000 times 2x equals 480. When I combine like terms, well, let's see, I have to multiply 5,000 times 2x first. We'll do that. 2,000x, and then 5,000 times 2x is 10,000x equals 480. And 2,000x plus 10,000x is 12,000x equals 480. Then divide both sides by 12,000. We get x equals 480 divided by 12,000. So I can divide the numerator by 10 and the denominator by 10. In other words, cancel a common factor of 10, and I can write this as 48 over 1,200. And then I can note that 12 goes into 1,200 100 times, and 12 goes into 48 3 times. So I'll write that as, did I say 3? 12 times 4, I mean. 12 times 4 is 48. And 12 times 100 is 1,200. 12 divided by 12 cancels, and so x equals 4/100ths. And this fraction, 4/100ths, in decimal form is 0.04. Okay, so we can say that the annual interest rate for the $2,000 investment is 4%. When we convert this decimal to a percentage, it's 4%. And the other interest rate is 2 times that. So y equals 2 times 0.04 is 0.08. And as a percentage, that's 8%. Yeah, I'll leave the rest of that for you to do. You can just write, if you were taking a test or a quiz, you could just write 4% is the annual interest rate for the $2,000 investment, and 8% is the annual interest rate for the $5,000 investment. Okay, let's move on to the next page. This is another mixture problem. This one says 200 liters of an 80% acid solution is produced by mixing a 50% acid solution with a 90% acid solution. Find the number of liters of each. So what we need, or what the chemists need, or whoever's doing this, they need 200 liters of an acid solution that is 80% acid. And they're going to get that by taking a certain number of liters that's 50% acid and a certain number of other liters that's 90% acid. And they're going to mix them together so that the mixture is 80% acid. So find the number of liters of each. So we have two quantities to find. So I'll pick X to be the number of liters. That is 50% acid. And I'll use Y to be the number of liters that is 90% acid. Okay, then we're going to mix the X liters with the Y liters to get 200 liters that is 80% acid. Okay, we need two equations. The first equation just involves the number of liters of each. So if I add X liters to Y liters, I get 200 liters. Okay, then the next equation, each term represents the number of liters of pure acid. Okay, so if X liters of a solution is 50% acid, how do we represent the amount of pure acid? Okay, if you had, say, for example, if you had 100 liters of an acid solution and 50% of it is acid, then how much pure acid is there in that 100 liters? 50 liters, yeah. If half of it is pure acid, 50% is half. 50% of something is half of that something. So it's 1/2 of that amount. So in our thought experiment, to find 50% of 100, you can multiply 0.05 times 100. And 0.50 times 100 is 50. Okay, but we don't know exactly how many liters is yet. That's what we're trying to find. So if X liters is 50% acid, then the amount of pure acid is represented by multiplying 0.50 times x. And then we're going to add that to the amount of pure acid in y liters if it's 90% acid. That is represented by multiplying 0.90 times y. And then the mixture that consists of 200 liters, the mixture is 80% acid. So to find the amount of pure acid in 200 liters, if it's 80% acid, we multiply 0.80 times 200 to find the amount of pure acid that 200 liters has if it's 80% acid. So 0.80 times 200. Okay, so make sure that you catch the subtle differences in some of these problems. We could have written this problem so that we were told how much acid was in the mixture. But we weren't told explicitly how many liters of acid is in the 200 liters. So that's why we have to use the percentage of acid and the total number of liters. And we have to multiply the decimal form of the percent times the total number. See what I mean? Since each of the decimals have 0 on the right, I don't need to multiply by 100. Well, multiplying both sides by 100 will get rid of the decimal, but I can also just multiply every term on both sides by 10 instead. And if I multiply both sides by 10, I'll get 5x plus 9y equals 8 times 200, which is 1600. Okay, so we're about out of time. Let's go ahead and use the substitution method. If I solve the top equation for x, I get x equals 200 minus y. And then in the bottom equation, replace x with 200 minus y, and then we can solve for y. So I get 5 times 200 is 1,000, minus 5y plus 9y equals 1,600. And we can do a couple of things at once. We'll subtract 1,000 from both sides and also add negative 5y to 9y. So we get 4y equals 600. And divide both sides by 4, we get y equals 150. And if y equals 50, then x is 200 minus 150, or 50. Okay, so we'll stop with that one. The next problem that we don't have time to do is like one of the problems that we did yesterday. Okay, so that's all for today.